Dear students, welcome to the fifth session of this module on strategy and practice. We will understand some basic concepts about the innovation strategies of firms. The first video lecture of this session talks about technology cycles. Here, I explain the concept of technology cycles. Understanding it will help us better define opportunities, threats, and potential competitive outcomes of a firm's strategic choices. A new technology emerges and its performance increases with R&D efforts or expenditure. Its growth trajectory follows an S-shaped curve, which I will show you in the next slide. Technology life cycle has three phases: introduction, high growth, and maturity or stagnation. Initially, in the introduction phase, a technology develops rather slowly. R&D involves a lot of experimentation and the actors create multiple technological options. There is much uncertainty about which innovations are going to be valuable and reliable. Many competing technological options meet a dead end. Let me give you an example of TV display technologies in 2000s when analog TV technology was being supplanted by the digital TV. So various companies were working on different technologies such as LCD, LED, OLED, and plasma TV. Uh, Companies like Samsung and LG were experimenting with and developing both LCD and plasma display technologies, which were competing options, right? Thanks to the aggressive development and commercialization of LCD by Samsung and Sony, uh, this technology emerged as a clear winner over time, and the LCD TV became established as the dominant product design. Now, with the lower uncertainty and due to higher average payoffs of the incremental R&D, firms focused on developing this technology even more, pushing the trajectory, this technology life cycle, onto the high growth phase. In the maturity phase, the technological opportunities get exhausted. The industry has been commoditized and R&D has very limited payoffs. So here you see the pictorial representation of a technology cycle. On the x-axis, we have plotted R&D efforts and expenditure and value creation on the y-axis. It shows the relationship between R&D efforts and technology development. As you can notice in the first phase, a technology emerges but develops very slowly. R&D involves a lot of experimentation. There is high technological and market uncertainty. That means the technology is not yet reliable, and we don't know whether consumers will accept products based on the new technology. The industry experiences high entry and exit rates. We also notice openness and cooperation in the industry. In the early high growth phase, we witness emergence of the dominant technology and product design industry, various ecosystems to innovate and commercialize the innovative products and markets. Technological uncertainty has reduced. Large firms enter the industry. There is high rate of innovation along the selected technological option. If you remember the previous example of digital TV display technologies, exploitation and incremental innovation becomes the primary mode of R&D. Openness of industry starts diminishing. Firms patent to protect their innovations. In the late growth, high growth phase, the technology is widely diffused in the industry and the market is saturated. Better and cheaper products are available. Large incumbent firms dominate the market and patent heavily to protect their innovations. In the maturity phase, the industry undergoes commoditization. Opportunities of R&D are exhausted in the technology area. Innovations don't have much payoff. In this slide, I explain you how an industry gets commoditized. In the initial stages of technology cycle, innovative firms have advantage over the late entrant imitator firms. As the technology is not yet reliable, even the products offered by the technology leaders don't meet the expectations of average customers. However, their products have a clear competitive advantage over the imitators who might be competing on efficiency. As both technology leaders and imitators develop the technology over time, their products meet customers' expectations. When an imitator's products meet market's expectations or consumers' expectations, it emerges as the market leader, lowering innovators' advantage in the industry and its incentives to further differentiate its products. Then competition is based primarily on efficiency and prices. Now let us look at the intergenerational technological changes in an industry. You can think of automobile industry, which is undergoing such a change towards electric cars. First of all, it is important to underline that progress takes place through a succession of technology cycles. Second, technologies change incrementally along one cycle, punctuated by large shifts from one to another cycle, which transforms the industry and may render the capabilities of the previous generation incumbents totally irrelevant. For example, over the decades, we made internal combustion engines less and less polluting. Then we shifted to a completely new technology which holds the promise of zero carbon emission, and we invented electric cars. So incumbents which are not able to adapt such changes in the industry and cannot innovate along the new technological trajectory are going to fail. This is a graphical representation of intergenerational technological change in an industry. The blue curve represents an old technology, whereas the orange curve represents a new technology. At some point, some inventors start experimenting with new technology, which is less reliable, gives them lesser competitive advantage in the short term, but promises higher efficiency and competitive advantage in the long term. This period, when the old technology gives more competitive advantage over the new promising technology, is indeed a period of uncertainty. Should your firm enter the new technology area in this period? This technology may also fail and have a dead end. However, this is also a window of opportunities. Your firm can enter the technology area, innovate aggressively and make it reliable, establish your innovations and products as industry standards, and thus shape the whole industry around them, around your products and innovations. So partly it is a matter of insight whether you correctly evaluate the new technology and its potential. Overall, the window of opportunity gives firms a low probability of very high success. Innovating in a mature cycle is exploiting known technological knowledge. You work on a tried and tested technology. Such exploitation requires a certain set of organizational structure, routines, and culture. Innovating in an emerging cycle implies exploring in a new, untested technology. Exploration requires different set of structure, routines, and culture. We will know about these two terms, exploitation and exploration, in more detail in the next video lecture. Normally, a firm innovates along multiple technologies which are in different stages of life cycle. So the firm requires an ability to conduct both exploratory and exploitative R&D. Such firms are called ambidextrous because they can do the both. And these firms are more likely to survive intergenerational technological changes in the industry.